In this video, we're going to look at how to solve multi-step equations when there are variables on both sides of the equation. The first example we're going to look at is this one. There are actually 4 correct first steps to this equation, but there are 1 or 2 steps that might be a little bit more efficient or make it go a little bit more quickly. I would suggest always getting variables on the same side of the equation first. So our options would be either subtract 8x from both sides or subtract 6x. Both of them will work, but the one that's going to probably make things a little bit easier is subtracting 6x from both sides. The reason I'm choosing to subtract 6x from both sides is because 8 minus 6 is a positive number, and if you can get a positive coefficient, that'll give you one less step later on. So 8x minus 6x is 2x. We still have minus 25 equals negative 35, and those are 0 pairs, so they cancel. Now that I have put variables on the same side of the equation, it's a 2-step equation, and we can continue by getting rid of the constant. So we'll add 25 to both sides, which leaves us with 2x equals negative 10, and then you can divide by 2 on each side to get x equals negative 5. Now I could do a check it step, but for right now, I'm going to skip that for this video so it doesn't get too long. All right, next example, there are some parentheses, so we'll use the distributive property to get rid of your parentheses first. So 2 groups of 1 minus 6x means we're going to do 2 times 1 and 2 times negative 6x to get negative 12x. And then I'll bring down the rest. Plus 4 equals negative 8 plus 2x. And just like before, I would benefit from getting my variables on one side of the equation first. So options would be either adding 12x to both sides or subtracting 2x. The way that is going to give me a positive coefficient is to add 12x to both sides. Okay, and keep in mind, there are other correct first steps, but I'm trying to show you a way that's going to be the most efficient, or the way that's going to give you the fewest number of steps. So we can combine those. We still have 2 plus 4, which you could combine if you'd like, and then negative x plus 14x. All right, I'll go ahead and continue by combining like terms. And now it's just a 2-step equation. So I've got 8 negatives with 14x. So to get rid of or cancel out 8 negatives, we're going to add 8 positives to each side. So we have 14 equals 14x. And from there, divide by your coefficient to get 1 equals x. And since we got a whole number, this one would be pretty straightforward to go back and plug in for the check it step, but I'll leave that for another time. All right, next one looks like this. So options are either subtract 3, add 4x, add 7, or add 4x. To get variables together first, we'll go ahead and add 4x to each side. And be sure you're always lining up like terms, so 4x would go under the x term on both sides. Okay, and on this example, something weird happens. All of the variable terms actually cancel out, and we're left with 3 equals negative 7, which isn't quite what we're used to. This is a false statement. Obviously, those two are not equal to each other. And so what that tells us about x is there is actually no possible solution for x. So for my answer, I would write x equals no solution. So even though I got a false statement, I can still write x equals no solution as my actual answer. So again, that just means there's no possible number we could plug in for x and have the equation be balanced on both sides. All right, next example, we'll go ahead and distribute first, since we see parentheses. So negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. Bring everything else down. There are 4 terms, so there are 4 correct first steps. I'm going to get variables together first, so I'm going to add 2x to each side. And so these form 0 pairs, and these form 0 pairs. So that same thing happens again where the variables cancel out, and I'm left with negative 2 equals negative 2. Now this time, the statement that I'm left with is true. And so this one's kind of weird, but there are actually an infinite number of correct solutions. That means x could literally be any possible number you come up with, whether it's a fraction, a decimal, pi would even work. X could be anything we wanted it to be. So as my final answer, I'm going to write x equals all real numbers. And that would be my actual answer for what x is. Now, I know that might seem a little bit weird because you might be wondering why we have to say all real numbers. There is such a thing as an imaginary number. You'll learn about that in a couple years. So for now, we're just going to say x is all real numbers, keeping in mind that there is such a thing as a non-real or an imaginary number. All right, we went through those last 2 examples fairly quickly, so I've got this page to kind of summarize the 2 different cases. If the variable term cancels out and the resulting statement is true, then there are an infinite number of solutions, and you're going to write down that x equals all real numbers. If the variable terms cancel out and the resulting statement is false, then there are 0 solutions, and you're going to write x equals no solution. So a couple different things that have come up. You have either an infinite number of solutions, 0 solutions, or in the case of the first couple where we had x equals 1, that would just be 1 solution. Or when we had this one, x equals negative 5, that would be an example of something that just has 1 solution, and you wrote down negative 5 as your solution. All right, final example for these notes. We're going to look at a word problem where we need to write and solve an equation in order to find the number of miles you need to drive to have the same cost for each of the car rentals. So we can imagine that there are 2 different cars that we're choosing between. The first one costs $15 to rent and 50 cents per mile. The second is $25 to rent and 25 cents per mile. So with any word problem, we will start by defining the variable. We're looking for either the question or when it says find something, that tells us what our variable is going to be. So I can write m equals number of miles. And then for each car, I'm going to write an expression based on what it's telling me. So a $15 flat fee means I pay $15, and then I'm going to add on 50 cents per mile, or multiplied by the number of miles. The second expression, I have a $25 flat fee, and I'm going to add in 25 cents per mile. So 0.25 is my coefficient, m is my variable. When I write them next to each other, it means multiply. All right, now that I have my 2 expressions, in order to find my break-even point, or the place where the cost is the same, I'm actually just going to set those 2 expressions equal to each other. And now I have an equation kind of like before, variables on both sides, and we can go ahead and solve it. So again, 4 correct first steps. We could subtract 15, we could subtract 0.5m, we could subtract 25, or we could subtract 0.25m. The way that we'll get a positive coefficient is to subtract 0.25m from both sides, and that's just because 0.25 is smaller than 0.5. So this is my 0 pair, And when I subtract, I'm going to get 0.25 m. So we'll bring down 15 plus and equals 25. Okay, now it's a two-step equation, so we will continue by subtracting 15 from each side to get 0.25 m equals 10, and then we'll divide by 25 cents on both sides. So since 25 cents goes into a dollar 4 times, 25 cents would go into $10 40 times. Okay, if you don't believe me, you could go ahead and set up that math problem. Do times 100 times 100 and 1,000 divided by 25 would come out to 40. So m is going to be 40, and since m represented the number of miles, we'll go ahead and write miles next to it. So again, 40 is the break-even point. That would be something helpful to add to your notes. And a break-even point is where you have two different situations and you're trying to find the place where the cost would be the same for either one. So if I go back to the original problem, the red car had a lower flat fee but cost more per mile. The yellow car had a higher flat fee and cost less per mile. 40 miles is how much it would cost to be the same for either one. And so if I'm going to drive less than 40 miles, I would want to do the yellow car. If I'm going to drive more than 40 miles, the red car would be a better option. And I may have just swapped that when I said it out loud, so I went ahead and wrote it in. Red car would be better for less than 40 miles. Yellow car would be better for more than 40 miles. All right, thank you for watching. These are your new rules, so be sure that that's in your notes. And good luck solving multi-step equations with variables on both sides.